Professor Bialis here. In this video we are going to be covering section 11.2, which is talking about the quadratic formula. The quadratic formula is the last method we're going to talk about for solving quadratics. So far we have factoring, then we talked about that square root method or square root property, and then we talked about completing the square. Factoring is great. I really would suggest sticking with that if it is factorable. That square root method is a really quick method if you just have a squared quantity or a squared x and you don't have that linear x where it's just x to the first. Completing the square is really good because it can be solved, or you can use that to solve any quadratic that I can throw at you. However, it's very cumbersome. This method that we're going to talk about here actually uses completing the square once, and then you can just plug and chug the rest of the way. Now, what do I mean by that? Let's see how we can solve, using completing the square, just the general quadratic ax squared plus bx plus c equals 0. That is a very general quadratic equation. Okay, so if I were to solve this for x using completing the square with those variables still in there, what do I end up with? First thing I would always do is get that constant isolated. So I would subtract c in this case. Okay, think back to completing the square. The next thing would be, if this number was something other than 1, I would divide through by it. Well, what is a? It could be 1, could be something else. If it is 1, it's not going to hurt anything, so let's just divide everything by it. That way we can clearly state there's just an x squared. And we're here. Okay? Again, what I'm trying to do is use completing the square to solve this general formula. Okay? So, once I'm at this point, I would take this b value, which now in this is b over a. It's really the coefficient of x. And then I would multiply by a half, or divide by 2, and square it. Now what I get with that is b times 1 is b, b squared. So I'm going to add a b squared on top. And then that denominator, I have a times 2, so 2a squared is 4a squared. Okay, so I add it there, and I add it here. Okay, now let's clean that up. This side, after we complete the square, which is what we just did, we completed that trinomial as a perfect square trinomial. We can factor that very easily. I just drop down the square root, which is b over 2a, and then I have this plus sign here, and then I square. Okay, that's a factored form. Now on this side, let's see how that's going to come together. I could leave it like that, but those of you who know the quadratic formula, the thing I'm about to get to, this is not really going to fly in that formula. So what we're going to do is go off to the side and combine this up a little bit. First of all, we need a common denominator. That common denominator is going to be a 4a squared. That second fraction already has it, so I'm going to bring the b squared over. Now this is missing a 4 and then the other a. So I'm going to multiply top and bottom by 4a. So I get the 4a squared down here, and now on top I have a negative 4ac. Now, again, in the formula, we try to keep those negatives out of the front of an expression just because it's very easy to lose them. So what I'm going to do is combine this into b squared minus 4ac all over 4a squared. Okay? Completing the square is technically done now. What I did, I isolated the constant, I divided that leading coefficient out, and then I added that square term on both sides. This was just me cleaning up that right side a little bit. Okay, so now I'm here. Once I get to this point, I'm thinking of that square root method. So let's continue with that. I'm going to square root both sides. This then drops out. And then don't forget always plus or minus. Now this expression here, I can't just take that square root because there's a lot going on there. So what I'm going to do is I'm going to leave that as just the square root of b squared minus 4ac. And then that denominator is just a 2a. Okay? Now at that point, all I need to do is get this x alone. So I would subtract that b over 2a. Oops. Let me come up here. And I have x equals negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. Okay? Now what I did is I completed the square on this general quadratic. If I can keep that pattern, which I would call a formula, then I don't have to complete the square ever again technically because I already did it once. Okay? Now, this is fine the way it is, but let's clean it up a little bit because if this is a formula we want to be plugging in again and again, let's make it as nice as possible. So, that's going to be opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay, and there's your quadratic formula. You need to have that memorized because this is not going away. Okay, so this is where it is coming from. Again, I completed the square. Now I don't have to do it again. This isn't just a formula that someone thought up off the top of their head one day. It was simply doing a process that we already knew. Okay, now let's make a complete official statement for this. So, the quadratic formula says given a quadratic equation in this form. Now, what do I mean by in this form? The key here is you have this thing equal to 0, just like with factoring. Okay? So, in the grand scheme of things, when you guys are trying to solve a quadratic equation, get 0 on one side. That should still be your first reaction. Because then, if you can factor it, great, you're done pretty quickly. But if it doesn't factor, you're also set up for this. Completing the square is a great method. However, it's not the most user-friendly because of all the fractions and everything that's in there. If you prefer it, go right ahead. Use completing the square. It will work for you. Okay? But in general, I typically see students either gravitate toward this or factoring. Okay? And mostly this. But if the factoring is there, I want you to use it. Okay? So, given this quadratic, then the x will equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Know that formula. Just say it again and again. If you go, if you Google search this and there's raps, there's songs, there's rhymes, you can use all of that stuff if it helps. Honestly, I just say it again and again and again. If you use it, write it again and again and again. Okay? So let's look at a few examples of this. So we're using the quadratic formula, and let's start with this. Okay? Now, the thing I want to point out with this, first of all, this does not look like this. We don't have that 0 on one side. That's the first thing we need to do. If we were completing the square, this would actually be a good setup. But if we're using the quadratic formula, I have to start by taking the 1 over. And we got that. Okay? Now, again, if this was just solve and they didn't tell you how, I would look and consider factoring, but there's no way we're going to get these numbers to work out. So quadratic formula honestly would be the natural progression. That's what we would use next. So I'm going to write it out. Opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay? Now, the a, the b, and the c are simply the coefficients within that quadratic equation. So, your a is 2, your b is -6, be careful with the negative, and your c is -1. And all that means is you are plugging it in. So, opposite of b is a +6, plus or minus square root of -6 squared. Now notice the parentheses I put around that. It is absolutely necessary to put that when there's a negative. It's kind of optional when there's a positive. I would just put it there no matter what. When you're plugging in that b, just put the parentheses. So b squared minus 4 times a times c all over 2a. And there we have it. Okay? Now we have to go ahead and calculate this. A lot of people, they pick up their calculator and they try to do this whole thing in one shot. That's not a very wise move because there's a lot of weird stuff that can go on with this radical. I would do that radicand first. So that would be 6 plus or minus the square root of something. We still have to calculate that. And then 2 times 2 is just a 4 on the bottom. Okay? So what we get, -6 squared is 36. Negative and negative is a positive, so this is really going to be a plus. 4 times 2 is 8, times 1 is 8. So 36 plus 8 is 44. Okay? Again, if the numbers get nasty and you want to use your calculator, that's fine. Do not include the square root just yet. Okay? Because if you did, you'd get some weird decimal. Now I can look at that and say, wait a minute, I need to simplify that radical as a 4 times 11. So that is 6 plus or minus 2 root 11 all over 4. Now I want you to notice something on this. We have 3 components to this fraction, and all of them are reducible by that same number 2. If this was, let's say, a 7, you don't have to reduce that. But if all 3 are reducible, it must be reduced. So, divide by 2, divide by 2, divide by 2. And what we get is 3 plus or minus square root of 11 over 2. Okay, and there's your final answer. Again, could you have used completing the square on this? Absolutely you can. There's nothing wrong with that. This is just another method. The problem with completing the square is that there is a lot of back and forth. There's a lot of, distinct steps. Here you literally just plug and chug. That being said though, if I give students an option and I have students who gravitate toward this and then a student who gravitates towards completing the square, the completing the square typically has the correct answer a little bit more often. Now, that doesn't mean that it's easier. It means that that step, that process, requires a lot of focus. This doesn't really, because again, you're just plugging and chugging. So when you're doing this, just stay focused and you will be fine. Okay? But please do not look at it and say, oh, I'm just plugging it in, whatever, and boom, 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 boom. Because that's when mistakes start to happen. Okay, so just be careful with this. This is a very straightforward method, but just be careful. Let's look at another one. Okay. Now, I think you would agree the issue with this one are those fractions. Can we plug those into the quadratic formula? Absolutely. But is that going to work out nicely for us? It can work out, but it's going to be a mess along the way. So while we could use fractions, I would still clear them out, just like we have since day one. So we got the 0 on one side, which is a good start. But now I'm going to multiply everything by 6. That way I get x squared minus 6 divided by 2 is 3, so 3x. 6 times 1 is 6, and we got a 0. Look at how much nicer that is. I would much rather be plugging in a 1, a -3, and a -6 than a 6th, a half, and a 1. Okay? Now, once we're at this point, I'm going to go back to that quadratic formula. Opposite of b plus or minus square root b squared minus 4ac all over 2a. So, remember, if there's nothing there, it's understood to be a 1. So a is 1, b is -3, c is -6. Let's write that down, actually. So we've got a 1 here for a. This is your b. This is your c. Okay? So opposite of b is a +3 plus or minus the square root of a -3 squared minus 4ac all over 2a. And what that gives us is a 3 plus or minus square root of something over 2. So we get 9, because -3 squared is 9. 9. Again, 2 negatives would make it a positive, so this is really going to be a plus. 4 times 1 is 4, times 6 is 24. So 9 plus 24 is 33. Okay? And now, always look at this radical and think, can I reduce that? And in this case, there's no perfect square that's going to go into that. So actually, that's it. All you really had to calculate was this. Okay? So there's your answer. We can move on. Let's do one more like this. Now, again, the first thing that we should be doing is getting a 0 on one side. Now, a lot of people want, well, there's just one thing here, so I'm just going to move that x over. But again, then we got a lot of negatives there, okay, especially that negative out in front. Like I said before, if this is factorable, I would want you to factor it, okay? So still, I would get everything over to the side that makes the x squared term positive. So that means I'm going to add this over, and then add this over. That clears out that right side. Now the left side is a 4x squared plus x plus 4. If you try to factor that, that's not going to work. So let's go into opposite of b plus or minus square root b squared minus 4ac all over 2a. So opposite of b is a -1 plus or minus square root of b squared. Again, those parentheses aren't necessary there, but they're not hurting. Just put them there. B squared minus 4ac all over 2a. Okay? And then we got -1 plus or minus square root of something over 8. Now, let's see what this is. This is going to be a 4 times 4 is a 16. 16 times 4 is 64. Okay? So 64, you got 1 minus 64 is a -63. Now, in the past, we would have looked at that and said, well, -63, we can't do that. We have complex numbers now. Okay, so continue. So I'm going to simplify this radical a little bit. 63 has that negative in there, but also you can think of that as a 9 times 7. Square root of 9 is a 3. Then that negative comes out as an I, and then you've got square root of 7. Okay? And that's pretty much all you got. If you want to separate those and bring that I to the side for that standard form of that complex number, you can. It's not necessary though. I would honestly just leave it like so. Okay? Let's move on to something a little different. They talk next about what's called the discriminant. I just want to touch on this briefly. Okay, so the discriminant is this expression here. Okay, now that should look familiar. That discriminant right there is the exact same thing as this radicand within the quadratic formula. Okay, now what they have you do is tell what the solutions will be like based on that calculation. So what that means is if this calculation ends up being positive, what we're going to have are two real solutions. If this calculation is equal to 0, we will have one real solution. And if this calculation is less than 0, we are going to have two complex, not real, solutions. Okay, now let me explain why that is, and then I'm going to say something else about this. So why is that the case? How is that telling us that? So that discriminant, the radicand of that quadratic formula, let's say we're going back here. We do that calculation and we get a positive value. What did we get? We got two real solutions out of that because you have the plus version and the minus version. If this radicand is negative, we got two imaginary solutions. Okay? Now what happens when it is actually equal to 0? If this part of the quadratic formula equals 0, then this plus and minus, you're just adding a 0 and subtracting a 0. That kind of goes away. So if this was equal to 0, all of this just zeroes out, and we're left with a single solution from the quadratic formula. Okay? So it's a very intuitive thing that follows from that discriminant. However, in my classes, I typically don't talk too much about that because why? Why do I care that I'm going to have two complex solutions? Find the complex solutions. Why do I care? Oh, there's going to be two real solutions. Find them. Especially in an example like this, you calculated that discriminant and then what? You had your answer. So why not take 2 extra seconds and actually find the answer? As opposed to doing 90% of the calculation and saying, well, I'm going to get 2 of these. Okay, find them. So that's why it makes perfect sense to look through this and see why this is happening. However, I don't see the usefulness of it. Okay, that's just my opinion. I'm not saying to just completely ignore it, but you might as well just go all the way and find the actual solutions. Okay. So what I want to do now is finish up with just 1 or 2 kind of application problems, and we're going to use that quadratic formula to solve these as well. So let's see what these look like. Okay. Let me read through this, but then there's going to be a lot of drawing that's going to show you what's going on the board. So it says, this is practice 6 on page 676. it says, given the diagram, approximate to the nearest foot how many feet of walking distance a person can save by cutting across the lawn instead of walking on the sidewalk. And the diagram they give you, imagine a sidewalk. Like this, and they give you x plus 3 here. This is x. And then they want to know when you cut across, that's 15 feet. Okay? So, yes, we have that sidewalk, but essentially what we have is a right triangle with x plus 3 here, x, and 15. Okay? Now again, this is practice 6. Now, honestly, regardless of what they're asking for, we're going to want that variable. We're going to want to unlock all the information within this problem. Okay? Basically decode it. So with a right triangle, remember we have that Pythagorean theorem, a squared plus b squared equals c squared. So a, I'm going to call x. Then the second leg is x plus 3. And then I have 15 as my hypotenuse. Okay? So let's go ahead and solve this. We've got x squared plus, I'm going to distribute this out. If you need to write that out twice to see the foiling, please go ahead and do so. So I'm going to have x squared plus 3x plus 3x plus 9. And then 15 squared is 225. Okay, let's clean that up a little bit. I'm going to combine like terms to get a 2x squared plus 6x plus 9. And then I'm going to go for that 0 on one side. So I'm going to subtract 225. To get 2x squared plus 6x. 9 minus 225 is negative 216 equals 0. Okay, let me get some more room here. Now, let's solve this using that quadratic formula. What we could do, if you'd like, is factor out a 2 first, just to make the numbers a little bit more manageable. If you're using a calculator, it's really not going to make that much of a difference, but let's say you can't use a calculator on this, okay? Then what I would do is I would take out a 2 to get x squared plus 3x minus 108. Okay, even if we're using the quadratic formula, factoring out that constant of 2 and then dividing it makes the numbers a little bit more manageable. So what we're left with is x squared plus 3x minus 108 equals 0. Okay? Now, quadratic formula. X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. Now be careful with this, because the a, b, and c here are different than the a, b, and c here. Okay? So just I don't want you to get confused with those two. A, b, c here were the side lengths. These are talking about the coefficients of that quadratic. So I'm plugging this in as negative 3 plus or minus square root 3 squared minus 4ac all over 2a. Okay, let's calculate that out. We got negative 3 plus or minus square root of something over 2. Now again, I know negative and negative is going to be positive, so I'm going to be adding here. 4 times 1 is 4. 4 times 108. 4 times 100 is 400. 8 times 4 is 32. So 432 plus 9 is 441. Okay. Now normally I would say let's try to reduce this radical here. And you can, there's nothing wrong with that. But the problem specifically stated, round your answer to the nearest, I believe, 1/10 of a foot. Approximately to the nearest foot, I'm sorry. So we're going to the nearest foot. So we're going to have to be rounding. So if we had to get a weird radical out of this, we're going to round it anyways. So I wouldn't bother trying to simplify that. So what we're going to get out of this are two different answers. -3 plus square root of 441 all over 2, and -3 minus square root of 441 all over 2. Okay? Now again, we're rounding to the nearest foot. And this whole time, we are finding x, which is a side length of that triangle. Okay? So whatever we get out of that, we're going to round to the nearest whole number. Now, this I would probably pick up my calculator and then just work it out. Now, when you plug this in the calculator, though, let's look at this one, for instance. Be very careful, because a lot of people type it in like this. And what you're telling the calculator to do is that. That's not the same. So when we're plugging this in, especially if you're using like a scientific calculator that has the whole problem listed on it, or a graphing calculator, you need to put another set of parentheses to hold that numerator together. Notice you will have a doubled parenthesis at the end here. Now, when you do that, let me calculate this out here. We are going to have -3 plus square root of 441 divided by 2 is 9. Now that actually worked out nicely. That came out exactly. So what we get is 9. Okay? And then if we wanted to do the other one, we would have what? Put the subtraction in there instead. And then again, divide by 2, we would have a -12. Okay? Now, again, these are two possible answers for x. If this was just a general quadratic, those would be our two answers. However, we're looking at this application here. X is a side length. We cannot have a negative side length, so that goes away. So the only possible answer we have is a 9 right here. If this is 9, 9 plus 3 is 12 right there. Now, is that our answer? No. Whenever we solve our equation, we have to do that, but always go back and verify that I'm answering the question that they were asking. In this case, they didn't care about these side lengths. They said, how much walking distance am I saving by going across? Here, I'm just covering 15 feet. But if I go all the way around, I'm going to be covering 21 feet. So how much am I saving? 6 feet altogether. Okay? Make sure you're answering the question, because especially now and going forward, they're going to be giving you word problems where they may say, okay, take your answer and now do 2 or 3 more steps with it. So always go back and look at that solution. Okay? That's pretty much it for this section. Again, quadratic formula you have to have memorized, because that's not going to go away, and that's something you're going to want to use for a long, long time. So get that memorized, write it down every time, say it to yourself as you're writing it down, and it'll get stuck up here sooner or later. Also, be very careful with the calculation. This is not a mindless plug and chug. There's a lot of stuff going on here. Do that radicand first, and then you can clean it up at the very end. Okay? One other thing, if you do get answers like this, that means we could have factored this right off the bat, and we didn't have to do the quadratic formula. Okay? But as you see, quadratic formula didn't hurt anything. But try to keep that factoring in, ready to use if it's there. Okay? So, as always, keep working hard. Let me know if you have any questions, and I'll see you next time.